F5-3, okay. You're trying to find the reactions at the supports, right? AX, AY, and NB. You laid it all out. Okay. You got 5 sine 45 plus AX equals 0. You got 10. Is that a minus 10?
Should be. It's going down.
Continue.
True.
Yes.
Right. So then you can say.
Okay. What about 5 sine 45?
Yeah. F.
Right.
And what about
What about NB?
I don't know if you want to say F prime.
It has to be going up.
Okay. What about AY?
Yeah.
Yeah. Up to.
I think it also has to be going up.
Well,
And that's
what do you mean by has to?
Because these are both pointing down.
Uh-huh. Well, what I'm more interested in is what you've already done on your these are your forces at pin A, which you probably should just draw right there, right? Kind of makes a little more sense to put them right there. You put AY and AX right there. You put NB right there. AY is going up. Got to be positive.
Yeah. That's why I just we were confused about this because we thought that you had said something about it that we're not.
Said something what?
We thought you had said something about not worrying about that, but I think we misunderstood.
I guess that's what the moment is.
Yeah.
Yeah. So moments. When you do a moment calculation, you figure out the sign when you're all done.
Right.
Depending on which way it's rotating. For Fx's and Fy's and forces, you know the sign.
It's okay.
You can't forget it.
Yeah. I guess my question was, what kind of a role do these distances play?
Well, you have 3 unknowns, and right now you only have 2 equations.
Yeah.
So you need a 3rd equation.
Okay.
What kind of equation is that going to be?
Then
Moment.
Here we get AY.
Yeah. That's how you solve 2D problems. Usually there's 3 unknowns, you got to do 3 equations.
Moment around what though?
Take your pick. 5, 5, 4. You've got, so I've got a beef for you guys.
Uh-oh.
Yeah. Now, here's what I do. When I look at the drawings here, I see your AY is going down, and I see your FY is going down, and I see your NB is going up. See that?
Oops.
And I look at this equation, and it says AY,
Yeah.
which is going down, plus Fy prime. And what is Fy prime? There's an Fy and an Fx. Oh, there's an F prime. What is, I don't get that.
This is F prime times 4/15.
Okay.
So minus. This is plus.
Okay.
So then
Can
this
we do that in the future? Keep things really clear. Fx
Yes, we can.
is AX plus 500 times 3/5 plus NB. Are you sure?
I don't think there's an NB there.
No.
Come on, you guys, wake up.
Whoops.
Yeah. You could fucking get it.
Yeah, yeah.
This is wrong.
Okay, so solve for AX again.
Yeah.
Then you got your moment equation. You got minus F prime times 4/5 times 5 feet plus NB times 10 feet. It's good. Minus
Maybe that's why they have
600 Newton meters or whatever, or feet, pounds, whatever that is. Okay, that seems good.
Say what? AX.
So X is minus 300.
Yeah, minus 600.
Oh, yeah. It's yeah. Right?
Yep.
Okay.
So then we can solve for
Plug it back.
well, I don't know what we can. Well, we know what
No, we just
NB
find
is.
ND from here.
Yeah.
That's it. Is that what we're looking for?
Yeah, we're looking for those.
AX, AY, and NB.
Yeah.
Well, AY now, huh?
Well, AY we
So
could
plugging back.
once we got this, we could have just found what AY was. But so that's
The forces there, yeah.
Yeah.
I don't know.
So it's,
Give it up.
it's 400, right?
I guess there was no hot Cheetos today.
100.
In the vending machine.
So NB is 100. Does that seem good?
Yeah, NB's 100.
So
That makes sense, right?
it's minus
Mhm.
300.
AY is minus 300.
AY is minus 300. Okay.
Sound good to me.
Sounds good.
And it's given up.
Oh my god. Oh, you bring up NB.
Yeah, I don't know why that happened.
Okay, so we're stumped here on moments, huh? Moments are going to be on the test. So what is the problem with the moments that you're trying to do?
They're good now.
I'm trying to find
I
the
kinda
y
like
and
that
x
one, though.
distance
That was
between
really
each force and the.
Do you want to do that one or not?
So we're using some trig to.
So let me ask you a couple questions here.
You got a pin and a roll
You're actually studying the 5 kilonewton force.
back here.
That 5 kilonewton force is at a what degree angle?
Do you want to try this one? Or do you want to
For the horizontal?
To the horizontal.
And the beam it's applied to is at a what angle?
I don't care, dude.
Right, okay.
So this is 45 here, this is 45 here. So then what's the angle between the force and the beam?
Oh, 90.
Okay, what's the definition of a moment?
Distance times force.
And what is distance?
4.
Closest approach of the force, line of force, right? To the point of axis. So what's the moment of that 5 kilonewton force about point A?
5 times 4.
Yep,
Which is 20. Whoa.
it's 20 kilonewton meters.
But do we have to find moment, the x moment and y moment for A independently, or is that?
You could.
But you don't need to.
No, wait, there is no x moment and y moment for A. There's just a moment.
What about?
But you could find the moment of the x component of this 5 kilonewton force,
Okay.
and you could say it's 5 times the cosine of 45 times 4 times the sine of 45, which is root 2 over 2 times root 2 over 2, which is 1/2, right?
Okay.
So it's 5 times 4 times 1/2, right? And then that's negative. And then that's, the vertical part, which is also times, cosine 45, cosine of 45. That's why you get 20, right?
Okay.
45, cosine 45 is turned into halves when you multiply by the square.
So what about when you find the 10?
But there's no MAX and there's no MAY. There's just an MA, guys. Yeah.
What about for the 10 kilonewton force?
Well, let's do it. You tell me.
Put an angle in here.
So it's just that force. What's that distance, sorry? Is the also 28?
So should we erase that one?
34.6, right?
One more room? Because we're doing this one too. Right now.
Yeah, I'm taking it. I got the whole thing on the thing. So yeah, you can erase it.
So
Feel
we're
pretty good
doing
about
the
that?
same one.
You're doing the same one they're doing. Yeah, you'll probably finish before.
Oh, did you guys just try this?
Alright.
So
Oh, right.
this is a pen
No.
roller. You said?
Pin and roller.
So
Pin's
normal
gonna have-
force and also the other.
Say what?
Force. Like it has normal
So
force.
then now it'd be to the roller?
The roller only has the normal numbers.
Yeah.
Yeah.
So this is a pin roller. So it has like 3 force acting on it. Like normal force on the other two, like X and Y.
You can grab that. Did you get the correct stuff
Yeah, I
too?
think so. Wait, so,
Good. Take that home and look at it, and we'll talk about it on Monday.
just gonna draw
The solutions are online. Go to the test 2 announcement.
It's like this. So it'd be,
Is very
There's a
wide
normal.
diagram.
yeah,
Yeah,
just to simplify it. Then, this is 45.
So this
This
is
is
So are we stumped here on moments? So you got,
this is perpendicular to the force.
No, I don't think so.
This line.
It's a roller.
Yeah.
And since it's,
So
it can't actually roll
how do we
anywhere
combine
because
this
it's attached to this pin here.
that distance to get?
So it can't roll.
You're doing the moment about point A, right?
It's only gonna be.
Well, for this one, you'd have to find the X and Y
Right?
because it's
Does that
not
make sense?
perpendicular
Like-
to the line.
well, you've got a vertical
Like
force.
this.
And what is going to be the moment arm of that force about point A?
Well, B is just a roller.
The closest distance
So
that
it
that
can't
line of
actually
action of
roll
that force comes to
attached
point A.
this here.
And this one?
Yeah, but you have
I don't know. I think there's a closer one. If you
Yeah,
extended
but
that
I
10
think
kilonewton
this
force
black
infinitely in
would
both
have some
directions,
movement. Oh.
What is the closest distance it ever comes to point A?
Yeah. So this just comes to class.
Yep. What is that distance?
Is 5 kilometers here.
And we
Right
just
here.
break this down.
Root 2 over 2.
And then that's the triangle
So
we
you
can
can
say
say
this
this
is
is at prime.
So then just make like another triangle.
3 root 2
Yeah.
Well, wouldn't it just
times
be
2.
this,
Or plus
this?
Yeah.
So something. Yeah.
Yeah.
Because we did that triangle.
And then this,
You want to do the F and Y?
3,
Root 2.
because it's 6 root 2 over 2. 3 root 2 plus 2. Okay. That's the moment arm. So go ahead and add that to your thing. Equation.
10 times.
this is a.
And what else gives you a moment about A?
So who do you have for X? For this part, do you involve full time? No?
Do you what?
Do you involve?
No, I think you just keep it at that. If you're saying that your XY system is
The
just
normal of the roller.
just like
So
that.
it's just-
Okay, what would
If
that
you're
be?
gonna rotate it,
Mm.
then you would have to say 45.
So what happens is
3 root 2 plus 6.
This is just X. So you could just say.
2 plus 6.
Oh, you mean this angle?
Yeah.
Yeah, this is, or
And D.
or you have it? Yeah. So,
This triangle.
This is parallel
It's
to this
fine.
distance, so we're finding this distance. Is it?
So like,
which is 4. I don't think we can assume it's 45.
this is
Because we know this is 45.
is.
Oh, yeah.
Three root 2.
Oh, yeah, so
Oh,
yeah.
I thought
This
that
is
was
Root 2 over
45.
2 times
I
6.
thought you were saying the 4 was.
This is,
We just do one.
Such that. No, I don't really know that it's super important that we know what the
Say
angle is.
such that.
I don't think you have to
Or
include that in
elements
this though,
of-
because they're just the X ones, so they're all gonna be just.
And that equals 0. Does that look correct?
To me, yeah.
Okay, look it over really closely for me.
Well, you know. it's
Inspect
just-
every part of it. And let me know if you see any issues.
Yeah, because since this is 45.
Here's like sign. Here's 5.
Okay.
Yeah, I guess.
These are their own minus.
See any possible
Yeah,
errors?
that's minus.
Oh, wait.
This is plus.
Wait.
And it's this way. It's positive, right?
Yeah.
This is plus.
Yeah.
So it's
Yes.
That's what I meant, X, yeah. I don't know why we're.
Okay, and you can help clarify that by putting a reference direction in front of your thing. And this is a sum, and you can do something like this, right? You're saying that that's considered a positive moment.
Okay.
And that will help key in the reader, the grader, that you actually are oriented properly in this problem.
If we don't include that, would you mark it down?
No, I mean, if you're changing, signs in mid-stride, that will mark you.
So how, we just tell this by looking at it?
Or you could decide.
It's your choice. If you want to make it this way, you're welcome to.
Then you change all the signs.
In which case, that would be plus, plus, and minus. Yeah.
It's still gonna be the same.
So you can by default do plus and then do this.
And likewise for you could do
Yeah.
this, and you could do this.
That's what.
Okay, that makes sense, yeah. Right, that makes.
Just to kind of be clear, it helps clarify things, right? Anytime you can add clarity to a mixedy, murky problem, you're better off.
That's good.
Okay, now you just got to solve all those things for AX, AY, and NB.
Where's that calculator?
Dope, dude.
We have 2 on
Yeah, what is sine of 45? Is the square root of 2 over 2?
Yeah.
So,
Yeah.
35 is square root.
X plus,
I don't know.
Figure out what
what-
this is.
Oh, wait, you don't need it.
6.
At point A, do you need this? Because put in the Y, C, D, Y, because that's at the point. So force that point, because you use that point.
At Y?
Yeah,
You're talking about movement?
Yeah, for this, because I have 2 unknowns.
Then you have to wait for NB. He's gonna find NB over there.
Okay.
And then you fly it backwards and you get AY.
Wait, you can't solve. Oh, yeah,
No,
you
no,
have
no,
it.
no.
We have NB.
Oh, wait, yeah.
Did you get it? 4.24. So what do you say? Oh, you just.
Equals 0.
mm-hmm.
Right?
Yeah.
Okay, so
Yeah.
here's up NB.
Then you
Looks
can
good.
solve
Let's
for
do that.
NB, because we have all
Solve
this.
for
stuff.
NB.
Oh, it's just.
And then
gonna
you
be
can figure
the
out
opposite
what-
of this, right?
Yeah, you just, yeah.
Oh, no, he doesn't.
Yeah,
He needs.
yeah.
Oh, you figure out what X was? Okay, so then.
Yeah, so you can plug in the NB value into the FY equation and solve
Oh,
for
yeah.
AY.
Okay.
Calculate all
So
this.
we need to figure out what that is. So
Yeah.
F1 is 5.
So it's like minus 20 over there.
Okay, yeah, let's just. So it's going to be minus 20.
So you got an NB of 8.04, so did they, good. Looks like you're getting some agreement there.
Sorry, my bad.
What are you trying to say, dude?
Maybe cosine 45.
It's the same thing, 0.7.
Wait, so you
It's not fine.
Yeah, you get some.
wait, what are you solving for?
You get
AY?
3.5. You get 3.5.
For this.
5 cosine 45.
It's 10.
Plus 10.
Oh, you got it.
So it's 3.495.
5.49.
That's
That's for AX and AY, they're the same value?
Not the same value.
Pretty close though.
Yeah.
Oh, yeah, really
Yeah.
close. Yeah. That is really close.
Very close.
Yeah.
Could be rounding here.
Oh, that makes sense because it's, yeah, 45.
It has to be equal. The value.
Yeah.
Not really.
I don't know. I don't
It doesn't have to be because it's not a two-force member.
know. Just kidding.
If it was a two-force member,
No.
then it would sort of have to be the same. But you've got this thing here going on.
Their AY is different.
Oh, you got 5.49 for AY?
Okay.
Okay, you guys try to figure out what's the difference.
Same problem.
You scrutinize their work? Yeah. You got the NB and the AX is the same.
Our AXs are the same?
And yeah, the AX should be minus. You guys should have a minus sign there, right?
Oops.
About the same.
And the AY they have is 5.49.
5.4. Huh?
AY. Let me check that.
AY is also, yeah.
Probably something about the moment.
Our moments are the same though.
Yeah, is it?
They
Or
got the same NB.
Yeah, they got the same.
That's weird. Let's plug that in the calculator.
So check your FY equation and see if there's any errors.
Okay, because you guys use sine of 45 here. We use
Same.
cosine.
It's the same.
thing.
Okay. Yeah, right.
So we have
Plus 10.
Minus.
What did you guys do?
Oh, wait,
You should get negative NB.
we didn't include the plus 10.
Oh, no. What?
Plus 10. Because this is that,
You dropped the
Yeah.
plus 10 at some point?
yeah.
No, I didn't. Did you drop it?
There we go.
Did we? No, we didn't drop the plus 10. Oh yeah.
It is.
Yeah, I don't know why.
Okay.
Yeah. Yep.
Does that bring them together?
Yep.
He said.
Yeah. I think
Yeah.
it's
You got about 5.5 then, yeah.
Yes.
Okay, good.
Cool.
5.0.
Nice. Cool, great.
Cool.
How many engineers did it take to solve a statics problem? 6.
It's a learning process, right? That's how we're
Yeah.
we're here.
Yeah. That's not on this though. But this is good reinforcement for,
Just like last time.
because why do you got to do moments? Well, that's why you got to do moments.
Yeah, makes sense. So what's the test again?
You got a practice test, right?
Oh,
Right over there.
Just those?
Yeah.
I don't want to erase this. It's so aesthetic.
Good, yeah, you can race. You got 20 minutes still for another couple.
Let's do some.
We got 2 teams now doing
I
522.
kind of feel like there's a moment there.
Where?
At A.
But you should show it if it's a moment over there.
What do you mean you should show it?
No? They don't show
No, they don't have
Why
to
would
give
they show it? I mean, there's no applied moment. I mean, if there's an applied moment, they would have to show it, but this is not. But there's
Sorry, I didn't mean to erase that.
so
My bad.
so what is
I think there's
a
moment here.
I don't think we do.
Or
what kind of support is A? What does it tell you?
A's of 10.
Focus. The pin A and the force on the hydraulic cylinder BC. There's a train has a weight of 25 pounds.
So do we have moment at A?
Determine the force acting at the pin A and the force on the hydraulic cylinder BC. No, pins don't have moments, right?
Oh, that's right.
Oh
Oh,
my
yeah.
God, you keep getting that.
So you just have an AX and an AY and an FBC. You have 3 unknowns, right? You know the direction of force B because it's a hydraulic cylinder. It's a 2-force member, right?
Yep.
So it's going in that direction. And the angle of that thing.
Well, they have vertical and horizontal.
What's up?
Your AX is this way.
Yeah.
Your AX.
The sign doesn't matter.
Yeah, well.
The direction you draw it doesn't
Yeah.
kind of arbitrary.
I guess there wouldn't be.
They're not showing point. Well, I guess they are showing point C, but you really just need to. What is the body of interest there?
A and B.
If you can do the free body diagram, what are you going to do the diagram of?
That way, you can say your AY.
The hydraulic member?
Yeah.
Really?
Okay, but.
A and B.
What is the? What are they asking you to find? Determine the force
Yeah, so
acting
you could. So you'd have to
pin
say
A
FBC times the.
and the force on the hydraulic cylinder BC when the boom is in the position shown. Those forces are acting on what? What's the common thing that the forces at pin A and the hydraulic cylinder BC are acting upon? So you have to find one body to do a free body diagram.
There we go.
Right now you don't have a free body diagram.
The beam.
You got too many things on it.
The beam is
The beam.
What's up?
The beam is the thing where all the forces are coming together. You're just going to draw the diagram of the beam. So you don't have point C on there,
So you can say.
and you don't have the thing. You just got forces acting on the beam.
Yeah.
And that beam is in equilibrium. So therefore, you can solve the equation of equilibrium for that beam if you know what all the forces are.
He's got
Now you've got an AY and an AX, a BX, and a BY. But you're only going to be able to write 3 equations. But you got 4 unknowns. So you have to reduce an unknown
Well,
somehow.
the AX and the BX.
Wait, don't the AY and the BY cancel out, right?
No, they don't.
No.
They can't cancel out because they have to add up to
Maybe you can find a moment
the weight, 725 pounds.
Right. Oh shoot. So then
But
it's AX.
you still have,
But these cancel out?
Yeah. That's
no, they don't. No, there's a way to get rid of an unknown. Because,
Oh, add this to this.
nope,
just to assume.
no, no assumption.
Really.
Because one of those
Oh.
pins is connected to a 2-force member.
The hydraulic cylinder?
Yes.
You're right.
Therefore, you don't have an independent BX and a BY. You just have one. You know the direction of that force. You just don't know the
But
magnitude.
there's moments, so it's.
What's the direction of the force at B?
It's just going.
And I don't think it's going that way, is it?
What?
Oh,
It's okay. If you did it that way, you would have a negative number for your final answer. But you might as well put a little bit of thought in there, and you'll probably get it in the right direction. Yeah.
Okay.
So that means, if you think about it, then AX is probably going to the left, right? Because it's going to be pulling back, because that
Yeah.
horizontal force from FB is going to be pushing.
Would it also be pointing down then?
And AY is probably going down. Yeah. So those the way you have them drawn is fine, but you should get negative answers for both of those.
Yeah.
Okay, now you can do the equation of equilibrium. Put in maybe some dimensions on there so you can tell what the distances are for the moments,
Yeah. So
and then crank away.
That was the moment to find.
Okay, so you guys have that.
I smell winners over here.
FPC times,
Yeah, it's supposed to be 1 foot.
that's a 1 foot, okay.
Yeah. 125.
How do you know it's 1 foot?
It says it in the diagram.
Where?
Right here.
Yeah,
Tiny.
because
That is not the moment arm for FBC though, is it?
no, the pin and B is connected.
Focus.
To the hydraulic cylinder.
There's FBC,
There's 2 forces, yeah.
and it tells you that it's 1 foot horizontally away from A and 1 foot vertically away from A.
Oh, to keep this from going
Oops.
down.
So you have to do just vertical.
And it's at a 40-degree angle.
Maybe X.
Interesting. I know.
Yeah. Okay. So it's not 1 foot. So we have to
So-
find this distance.
You have to, no, because you got to find the perpendicular, and it's a 40-degree angle. If it was
whoops, yeah.
45, it would be pretty easy, but you
Yeah,
can't do
yeah.
that either.
Okay.
It's 40-degree angle. So how are you going to find the moment of FBC about 0.8?
Should we do like separately, horizontal and vertical? Moment
I would do
of
it.
FBC.
You can find the horizontal component of FBC and the vertical component of FBC.
Climb on the
And do
ledge.
those things, so you know the distance to A from those. Or you could just do the moment at B.
Yeah, that's what I was saying. Oh,
And AX and AY are vertical,
yeah.
so those are easy to find the moment arms.
Sounds logical.
And W and F are vertical, so just do that.
Yeah.
Let's do X.
Right? Either way, you'll get the same answer.
Negative
Yeah.
AX
AX.
plus.
I'll give you the same answer.
Either way, you get the
This
same
is
answer. Yeah, you have to.
FBC Cosine.
Laws of physics don't change if you analyze it at a different point.
Right.
So you could do it both ways. Prove it. Wanted to. You got your Fy equation
Or we
is
just do it. Well, anything.
minus Ay plus FBC sine theta sine 40 minus 25 minus 600. Yep, and Fx minus Ax
Yeah, that sounds easier.
plus FBC cosine of 40.
Does the direction of our forces matter here, though, right?
Sure does.
So
So I would recommend always in moments do the magnitude first and then figure out which way it's spinning.
right, but like if we had drawn these in like opposites, like
Yeah.
if we put up and this was to the right,
Yeah.
then would that change our answer?
No, it would just
It would just change
change
our
the sign of your
signs.
answer.
Okay.
Yeah. Yeah. If you had your AY going up, you'd have an opposite sign.
Okay. So I guess okay.
And then do we have a moment?
Yes.
No.
So then it says 125.
No.
Times
So B is a
Pins are
pin.
just there, right?
B is a pin.
3.
No, it's not.
No, rollers.
Mm-hmm.
B is a pin.
This is then
Well,
this is
like
minus.
it's like a cow.
Yep. Question.
Rollers or pins, which one has a moment? Which
9.
Rollers and pins. Which one has a moment? Neither has a moment.
neither.
What support does have a moment?
Um,
The one that's buried into a wall. What's that called?
Direct contact?
Nope. Starts with F.
Digits.
Digits.
What kind of support has a moment?
What is it?
Starts with F. I. X.
Fixed support.
Fixed support.
Fixie support.
Yeah. All
Okay,
right.
cool. So it's
But B is a pin though, right?
they don't have moments. So pins.
So B is a pin and A is a pin.
But this.
I'm guessing that would be a
Wait,
fixed.
did you
There's
grab
no
meeting?
moment
there's no
around-
What are you talking about? Moment around what?
Don't we need a moment for the third equation?
Yeah, you need a moment. And you can pick a moment and do a moment anywhere.
Oh.
And it has to add up to 0 no matter where you pick. You can do a moment at A, you can do a moment at B, you can do a moment at C.
Moment of G is at the
Really?
hydraulic thing.
Yeah. So you do almost
Or a moment at G.
Yeah, but like
One of those is really easy though.
Isn't B usually?
But B.
I think you
B
do, though.
doesn't have a moment.
So you can still do it there, you said.
Which one?
So you can
So when I say it doesn't have a moment, we're talking about how the supports are going to react to any loads that are given, right? And a pin is not going to add a moment to the system to keep the thing.
Itself.
Pin cannot add a moment, but the sum of the moments about the pin still has to be 0.
This is what I was doing before.
B is cooler.
Or maybe, oh wait, no. Yeah, maybe you can just do it like that. Oh, no, you're right. Yeah, I'm sorry. Yeah. I was doing-
So that is
That looks great.
1 feet, 1 times
No, but this says 2 unknowns.
2 unknowns.
40.
Yeah,
I mean times
No, it has AX and AY.
What's this? Oh.
Or
Yeah.
maybe we should just do that.
of course.
That only has one unknown.
This one, yeah.
Interesting. This one is easier to write, but it has 2
It has
unknowns.
2 unknowns.
And this one has 2 unknowns. And that one has 2 unknowns.
Let's use the one with 1.
Well, or do a matrix solution for the 3 unknowns. But yeah, it's nice when you can just get the solution with 1 unknown, with the equation with 1 unknown in it, right? You can solve for FBC, and then you can do the other ones really easily. Yeah, let's go do that then.
What is FBC?
I was thinking it was
Oh, wait, let's simplify this.
Are you good?
Yeah, I don't want to like plug it all in right now.
Because he said.
You could just factor out FBC though.
So then we're just saying that this force is 40. So this force right here
No.
is 0.
No, we're finding the we're finding the
The
moment.
moment there is
At
zero.
this
The
point.
force is.
There's no moment from this force. This is like
1.41.
So.
we talked about.
Then we find.
Which is equal to 0, right?
Isn't there more?
You mean if it was squared? It would be squared.
Yeah, there's more. What's else? What's giving you a moment about B?
Oh wait, this
125 times.
this this force is perfectly square.
Minus.
It's like 1,
Yeah, but that would also be 0.
So 50.
The moment of AX about point B. What would that be, Jose?
Wait, does it have what about AY?
Well,
So it'd
we
be-
can talk about that next, but let's start with AX. What's the moment of AX about point B?
That would be 1 times. Yeah,
Right?
one.
It's telling you the distance is
Yeah, they both have.
1 foot, right?
Mhm.
There to there is
Oh,
1
yeah.
foot.
Yeah, they both have. the same.
So you got AX times 1, and you put a negative sign in front of it. What's your reference direction? Counterclockwise positive.
Like
Yes.
Oh, that's 6,000.
That's clockwise.
Okay, if you want it that way, that is correct. I mean, this makes this correct.
Yeah.
Oh,
yeah.
right.
Wait, does it?
Yeah.
Yeah, because this is actually going this way.
Yeah. Yeah.
And that would make that correct. But then you got to do that same sign convention for the rest of your components.
So divided by 1.4.
Anything else is perpendicular?
Oh.
So what's the moment of AY about
So you
B?
get this.
See that how that number?
Yeah, you
Wait,
get
which is-
4, 2, 7.
You don't like doing it that way because it's confusing, so go back to the normal way.
But then we have to change AX to
Make that a-
positive.
Yeah, positive. Yeah.
That's confusing.
Why is that confusing?
Because to me, it looks like AX is just in the negative.
But it's like
Yeah.
pulling
Remember what I said? To
Yeah.
forget about the sign. When you're doing moments,
When you do
you
moments,
forget
forget
about
about
the
the
sign until you're all done, and then look at the direction that it's trying to rotate.
That's right.
And don't ever do that with forces or I'll kill you. All right. Thank you. I mean
Okay,
it.
so
I'm going to
then-
stand over you while you're taking a test.
Plus 1 times AY.
So 3, 2, 7, 6. These are big numbers, dude. I don't know if you're right.
With this equal to 2?
What?
Taking you one about B? Sure is.
Well, this is big number.
So
Yeah,
that would
why is
be
it so-
so 4 times.
I guess that makes sense.
Yeah.
Yeah, that makes
4?
sense.
Yeah, because it's distance
3.
or 3, right? 3.
There's no points on that?
Yeah, 0.1.
I don't know if it's right. This is a big number.
Big number. Should be a big number, though.
Should be a big number?
Yeah, you got a lot of forces.
Oh, yeah, true.
Mm,
And
It's super close
the
to
moment arms are pretty small, so
Yeah.
the forces have to get pretty big to counteract those.
That's TV.
So then we don't think-
But AY, you can check this AY,
We're doing it right now. Yeah.
FBC minus AY equal 725. Should. I can pull up the answers. Yep, those working out okay?
Yeah, we fixed
Getting
it.
it? What was it? You had an error?
Yeah, we had a 5 here.
Wrong moment arm?
Yeah.
Okay.
Oh, thanks. That's mine.
Okay,
It does have my name on it.
Yeah.
so very good.
So we
And
fixed that one.
Yeah.
awesome.
What is it for?
4187.
41.
So yeah, this is 3208.
Good. That's what it's supposed to be.
Yep.
Any final thoughts here? You getting it?
Pretty good, guys. So.
Minus 375. minus- Yep.
That one.
So you get, yeah, you get one equation involving FBC and AX, one equation involving FBC and AY. You
So we have to plug
could,
this into that.
I mean, you could,
Time's up.
You down to it?
I mean, if you want to, yeah.
Yeah, maybe this one.
No, we just did this one, dude.
What we did?
Yeah, we set up the 3-body diagram. Yeah, that's what this is.
Where's the first one?
Oh, cosine problem.
yeah, I mean, you could
Okay, then
Just solve
solve for FBC and substitute, you get AX. It's not very pleasant, but you can actually get two equations of two unknowns and do like a simple matrix thing to solve it. But you're on the right track. You got the, I think it looks good. And it's kind of time to go, so I'm going to go. You can stay if you want. The answers are right over here if you want to check your work, and they kind of took it to completion.
Okay.
But they did a different moment. They actually, interestingly enough, I'll show you guys this one. You are correct in that the moment equation at MB is a lot simpler. However, you get two unknowns in it.
Yes.
Whereas if you do the moment at A, you only have one unknown, FBC. And even though it's more complicated, you can solve it algebraically easier to get the answer. So that is something you kind of have to learn that by just exploring and trying it out. You can't really know until you just do it. Basically. So great job, guys. Seemed like
Oh, yeah, I know.
seemed like it was kind of helping clear stuff up for people. Hopefully.
Yeah.
We were going to do this one, but